Thanks, Neil. We will follow up. Our next speaker will be Ali Khayrallah, who is with Ericsson, or more specifically Senior Technical Advisor with the Advanced Technology Group at Ericsson in Santa Clara, California. He is currently focusing on 6G in the US in various partnerships with government, academia, and industry. He has worked with Ericsson for a long time and contributed to various technologies, 5G, 4G, 3G, and others. And also during this course, he has collected a number of patents and also received the Ericsson Inventor of the Year Award. And he is a graduate of the University of Michigan, holding a PhD in Master of Science. And he will now speak on securing open networks. Please welcome Ali.
Can you hear me okay? Yes? Okay, so I've given a couple of talks on 6G recently, and I found this picture with the urban landscape with the fog in the Ericsson corporate series. And I think in this context of open source and open RAN, Ericsson is kind of coming out of the fog and the shadows. So you heard this morning my colleague spoke about us joining OAI. So the big aircraft carrier is turning, and now finally we are kind of aligning. But as you know, we have been working for a long time, not only in our home court in 3GPP and so on, but also in the Open RAN Alliance. And today I'm talking about securing open networks. Recently, one of my colleagues became the co-chair, I think, of the security working group in the ORAN Alliance, because we think this is a very critical part of getting this stuff going. So for a change, I don't feel like I'm being sacrificed by my company. Now we have infiltrated you, we're part of you, so you have to be nice to me. So here we go. Oops, and now we have gone the wrong way. Okay, so as you know, working, yes. If you consider the 5G architecture in a very high level, 3GPP has traditionally defined, of course, the big interfaces between the infrastructure and the terminal, but also between the core and the radio access, and then we have the CU and the DU and so on. And in the ORAN Alliance, we have defined, the SMO, which is somewhat of a new function, which has the non-real-time RIC in it, and then you can talk down into the RAN, where you have the near real-time RIC and so on. And we have also the lower layer split, which has been a very complex discussion because, of course, the big vendors have deployed 5G before the LLS and the ORAN Alliance happened. So we had this kind of difficulty, but now things seem to be moving forward. But you are familiar with this big picture. Now, what is the security problem? I don't think I have the word ORAN on this slide on purpose, because I think the really revolutionary thing that is happening in our business is the move to the cloud, taken in a large sense. And the biggest impact is not on computation and baseband and so on, because an Ericsson base station looks very much like hardware in the cloud. It's not that different. But when it comes to security, this is where you have the biggest impact, because now you are a part of a computational platform where you are sharing with others, right? And so you cannot claim that, oh, this is my hardware, only has this interface, I trust myself, no problem. My security issues are on the perimeter of my hardware, right? So there is no such thing as physical isolation, if you will, if you want to have that picture in mind, like in a network appliance or a network box. So now every interface is an attack surface, right? Because the same way that you can use the interface to read from inside the network because you need the data, or to write into the network because you want to control something, that is also how you can attack the network, okay? And if you want to inject data into the network, coming from outside, for example, that's the same problem. You have to trust this external thing that is sending you data that you can trust, or any such. And it's not just about the RAN that we're this crowd is talking about today, but it's of course the same for the core network. It's the same from on top of the network, all of it. Anytime you are exchanging data, reading data, writing data, this is a security issue. So now we talk about zero trust. It's kind of a concept, if you will. It's a way of working. So you have to bake trust into the network. You cannot trust anybody or anything. Like there's no like, oh, this is one of our guys, it's okay. No, it's not okay. And you have to have explicit verification of everything, which is a lot of work. And you say, okay, well, we can't go down to the register level and check everything. So you do it. You can do it in phases. Right? So you can start with the big boxes and then smaller boxes and smaller boxes. So you can have phased approach. And I think when I was looking some background, I think Google was the first company that kind of identified sort of formally this notion of zero trust, where you have to worry about trust not just at the perimeter of the module, but inside the module and so on. I think back in 2009, 2010, they had a big attack on their facilities. So they had to kind of rethink the way they do things and so on. Now, of course, since then, it has been formalized more and more. There's, for example, this NIST document that came out a couple of years ago, which kind of formalizes what we mean by zero trust architecture. Essentially, there's no implicit trust. Everything has to be verified. Okay, so having established that, so now we get a little bit more into the specifics of the RAN and ORAN. Keep in mind that interfaces are there, whether, when the 3GPP crowd is not happy with the ORAN crowd, they say, oh, they have all these interfaces, now this is going to be more attack surface. Well, whether it's a standardized interface or a proprietary interface, or you don't even call it an interface, it's there. So if you are in a cloud environment, in a server environment where things are shared, you have to worry about it. So I think we need to set aside this idea that, if you define an interface, you're adding security problem. You may be adding obvious security problem, but the security problem is there. Right? So the picture shows you kind of another variation on the architecture. One of the things I want to point out is on the right-hand side in my picture, there's this notion of enrichment information, so that if you have your network and you need kind of external information to come in, right, because it's telling you something. I mean, my favorite example where I'm trying to use this kind of picture is if you're doing spectrum sharing and you have an entity outside which informs you, for example, that this particular band, you can use it now, or you shouldn't use it now, or you should use it partially or whatever. Suppose that entity is NTIA or some intermediary between the government and the operator, then it might be able to talk to you through that interface, right? So obviously, this is a case where data or commands are coming from the outside. So again, you have to establish how you can trust this outside entity to that whatever it's telling you is valid. So everywhere you deal with these things, you have to have security in mind. Now, if you go way up on top of the network, there was like in recent months, there was an announcement that there's something called Camara project, which is under the Linux Foundation, which allows for so-called network APIs. So from way up, you allow developers to write applications that sort of exploit the features of the network. This is not at the RAN level or at the core level. This is like commercial application. But again, if I'm going to allow, first of all, the API has to be designed properly, but also if I'm going to allow an external entity to talk into my network and configure it to some extent, this is, again, something that needs to have a whole security process. And Ericsson supports this Camara project, and I think we mentioned that the working group 11 in the ORAN Alliance, Ericsson is part of it, or co-chair of it. So now getting into a little bit of the details. I mean, we hear more than once, even today, I think, that open source is more secure. And the rationale is that you have more transparency, more visibility into the actual source code. You improve the chance of catching whatever malicious thing is going on, or even if it's just an oversight, right? And so people say this is the opposite of security by obscurity. Now, so at the potential level, if you think of some kind of Shannon limit, knowing, having visibility into everything is by far the best, right? So if you say, oh, I don't let you look at my source code, so you don't know what it's doing, so you cannot mess with it. Well, that works great until somebody can see your source code. So we have, so it's there. This is the essence of the problem. Now, when we have like open source communities and so on, like the OSC, they have defined, to my knowledge, like ways of working, things they have to check to make sure that they are satisfying the security requirements, even at the writing level, right? I think one of the problems with open source communities is that there is no strong incentive for somebody to volunteer their time, say, in order to do the security features compared to some functionality that where they will, they can brag about, look, I added some feature to the open source. Whereas security sounds like you're maintaining the open source or something like that. So we need to think of ways to incentivize participants so that they keep the quality of the security. So it's not really a technical problem, but it's something we need to think about. So in the ORAN software community, we have a subsidiary of Ericsson called Ericsson Software Technology, which contributes, and I think it was listed on one of the presentations. So it's not only our community that's interested, DoD is interested. They are a very strong proponent of open source, and they're very aware of security. And so there's this DARPA AI cyber challenge, which was launched a few months ago. Basically, secure the nation's most critical software, right? So both the so then we have the OpenSSF under the Linux Foundation, which this is a project to improve open source supply chain security, and Ericsson is a premier member. Ericsson has never met a committee it didn't want to be part of. This is why we're part of everything. And this OpenSSF itself supports the AI cyber challenge. So at least, the right communities are sensitized to the problem and are working on it. So that's the good news. And then some conclusions. So we need to be aware that it's the move to cloud-based networks that is really challenging security. It's not so much what we're standardizing and what we're leaving as proprietary and so on. The kind of attack surface is there, which we need to deal with it, right? I think this is probably the biggest challenge in the medium term. As we're moving from 5G to 6G, we're becoming more and more cloud-based, and we're assuming that 6G would be cloud-based. Of course, cloud technology will move along the way, but make that assumption. So, and that assumption needs a lot of attention to security. And then zero trust architecture needs to be baked into these networks. We can't come in at the end and say, oh yeah, add security, it'll be fine. And then a lot of the mobile networks today are considered critical infrastructure, whether they're public networks or they're dedicated private networks. So even public networks are considered critical infrastructure. So if you want to say we want them to be open, then it becomes crucial to have security on top and baked in order to be both open and satisfy the requirements of being critical infrastructure. And then, of course, there's a lot of work to be done on the mechanism for securing open source. And I mentioned, both the DARPA project and the OpenSSF and how it's all coming together. And that's it. Yeah. Question.